Hi everyone and welcome back to another lab. In this video, we will go over DHCP configurations on a Cisco router using iOS system. Understanding dynamic host configuration protocol is essential for automating IP address assignment and ensuring efficient network management. This is a key skill for any network professional. So by the end of this video, you will be able to configure a Cisco router as a DHCP server and set up DHCP pools for multiple subnets. You will be able to exclude specific IP addresses for the DHCP pool for infrastructure usage. You will also be able to verify DHCP configurations on both the server and client devices. So as usual, I will give you an overview of the DHCP protocol, then I will go over the lab topology and lab objectives. After that, I will go over the lab tasks, and then finally, I will walk you through the lab solution. So first things first, I'm going to give you an overview of DHCP, and then I will walk you through how DHCP works in the background. So DHCP stands for Dynamic Host Configuration Protocol, and it is a network management protocol used to automate the process of assigning IP addresses and other essential network configuration parameters to devices in a network. This automation ensures devices such as computers or printers and smartphones can communicate efficiently without the need for manual configuration or manual intervention. So DHCP simplifies network administration, particularly in large-scale environments, by reducing the risk of human errors and ensuring consistency in IP address allocation. So regarding how DHCP works, when a device, also known as a client, connects to a network, it requires an IP address to communicate. Without DHCP, an administrator would have to assign these IP addresses manually, which is not scalable. So DHCP automates this process through a client-server model, typically involving a DHCP server and a client device. The communication between the client and the server follows certain steps. So the client sends a broadcast message known as a DHCP discover to find available DHCP servers. This message is then sent to the network's broadcast address because the client does not yet have an IP address to target a specific server. Upon receiving the DHCP discover message, one or more DHCP servers responds with a DHCP offer message. This offer includes an available IP address, subnet mask, default gateway, and DNS server details, and the lease duration for the IP address. The client selects one of the offers and responds with a DHCP request message to inform the server of its choice. This step ensures that the selected IP address is reserved for the client. The server confirms the lease of the IP address by sending a DHCP pack message, and at this stage, the client is officially assigned the IP address and can start using it for network communication. If the server cannot fulfill the request for any reason, it sends a DHCP NAC message. And by the way, NAC stands for negative acknowledgement, which prompts the client to restart the process. One other thing that I wanted to also share with you is that DHCP is not limited to assigned IP addresses only. It can also provide other critical network information such as the subnet mask, default gateway, and DNS server addresses. This comprehensive configuration allows clients to function seamlessly within a network. In addition to this, DHCP supports IP address reservations for devices requiring static IPs, ensuring predictable communication for servers, printers, and other critical devices. So the primary advantage of DHCP is its efficiency and scalability. In environments with hundreds or thousands of devices, when you manage IP address manually, would be time-consuming and prone to errors, such as IP conflicts. So DHCP eliminates these issues by automatically managing address allocation, freeing up administrators for other tasks. So with regards to the lab topology, we have a single router, which is router 1, that is going to act as the DHCP server, which will be responsible for assigning IP addresses to each end device that you see in the network. So R1 is connected to a couple of switches, switch 1 and switch 2, and each switch is connected with a couple of hosts for demo purposes. PC1 and PC2 will be part of the 10.1.1.0/24 network, and PC3 and PC4 will be part of the 10.2.2.0/24 network. And the main objectives is to complete all tasks of this lab and provide connectivity between all PCs using DHCP protocol to assign IPs across all end hosts. So regarding the lab tasks, we will start by doing basic configurations on router 1, where we need to enable interface gig ethernet 0/0/0 and gig ethernet 0/0/1 with the appropriate IPv4 address settings, and we would need also to enable each interface. After that, we will enable DHCP service on the router, and then we're going to jump into step 3, where we are going to define a range of IP addresses to be excluded from being offered by the DHCP to the end devices. After that, we're going to jump into step 4 and 5, where we need to create a DHCP pool to set up the network address, the default gateway, the DNS, and the domain name information for each network. Next, we're going to go to step number 6, where we need to log into each PC and release the current IP address that has been assigned and renew them to check if the changes has an effect. Finally, we're going to go to step number 7, and we are going to perform some connectivity tests, and that would be the end of our lab. Okay, so this is the moment where I ask you to pause the video and try this yourself to test your knowledge and skills. So I have added the lab document in the video description so you can download it and practice at your own pace. I have also included a couple of packet tracer labs for you to download. You will find a pre-lab and a post-lab version. The pre-lab is for those who want to tackle all tasks from the beginning, while the post-lab provides the full lab solution. Okay, so I'm going to jump into the first task, and I'm going to go to router 1, and I'm going to go to the CLI, and then I'm going to go to user privilege mode, and from there I'll be able to go to global config. So I'm going to say configure terminal, and I'm going to tackle interface gig ethernet 0/0/0 first. I'm going to say description link to switch 1. I'll set the IP address with 10.1.1.1, and the subnet mask is going to be 255.255.255.0, which is /24. I will enable the interface by saying no shutdown. And then I'm going to jump into the other interface, which is gig ethernet 0/0/1, which is connected to switch 2. So I'm going to say link to switch 2, and then I'm going to set the IP address with 10.2.2.1/24. And also we need to enable the interface. And then after that, I'm going to perform some in-flight checks. So I'm going to say show IP interface brief. And you can see that we've configured these two interfaces, each interface with the appropriate IP address. And you can see that each interface is in the up state. So what we're going to do next, we're going to jump into step number 2, where we need to enable DHCP service. And just to let you know, by default, the DHCP service is enabled on Cisco routers, meaning it is active unless the no service DHCP command is present in the router's running config or the startup configurations. However, it is generally recommended not to depend solely on these default settings when configuring DHCP on a Cisco router. So I will go to global config once more, and I'm going to say service, and if we question mark, you will see the content sensitive help, and as you can see on the screen, it does say enable DHCP server and relay agent. So I'm going to say DHCP. Now that we've done that, we can then move to step number 3, where we need to exclude certain IPs for critical infrastructure devices. So I'm going to say IP DHCP exclude -address. So at this point, if we were to issue the question mark, you can see that we need to include the lowest IP address. So I'm going to say 10.1.1.1. And remember, this IP address is assigned to interface gig ethernet 0/0/0. So we will say that the first 100 IPs will be reserved for infrastructure purposes. And then if I question mark this again, we would need to set the highest IP address. So in that case, we will say 10.1.1.100, which means that DHCP will exclude these IP addresses starting from 10.1.1.1 and is going all the way to 10.1.1.100. And then I'm going to hit enter. And then I'll do the same thing for the other network. So I'm going to say IP DHCP exclude -address. And I'm going to say 10.2.2.1 as the lowest IP address of that range. And the highest IP address is going to be 10.2.2.100. And then I'm going to hit enter, and then I'm going to hit end. Now let's perform some in-flight checks. So I'm going to say show running -config pipe section DHCP. And you can see the configurations have been applied on the running config. Next, I'm going to jump into step number 4, where we need to create a DHCP pool for the first network, which is 10.1.1.0/24. And we're going to use a specific pool name, which is defined by the playbook. So again, I will go back to global config and I'm going to say IP DHCP pool, and here we would need to specify the pool name. And in my case, I'm going to say IEE underscore network underscore 1. I will hit enter, and here we will be able to set the network address, the default router and DNS server, as well as the domain name. So I'm going to say network 10.1.1.0, and the subnet mask of that network is going to be 255.255.255.0, which is /24. We are going to say the default dash router is going to be 10.1.1.1, and also we're going to specify the DNS as well. So I'm going to say DNS dash server, we're going to say 8.8.8.8, and then after that we will also need to define a domain name. So I'm going to say domain dash name, I'm going to say iee.com. I will hit exit, and then I would need to create another DHCP pool for the second network. So I'm going to say IP DHCP pool, and again I'm going to call it IEE underscore network underscore 2, and I'm going to set the network first, which is 10.2.2.0, and the subnet mask is /24. I'm going to set the default router, which is going to be 10.2.2.1. I will set the DNS server as well with 8.8.8.8. I will set the domain name to iee.com, and then I'm going to hit end. So at this point, we can perform some post checks, and the post checks that I'm going to perform at this point is just checking the current config and make sure that all the commands that we have executed have been taken and they are good to go. So I'm going to say show run pipe section DHCP, and here you will be able to see that we have got a couple of configurations here that related to DHCP excluded IP addresses, and here you will be able to see the DHCP pool for the first network, and this is the configuration under the DHCP pool for the second network. Okay, so I'm going to jump into step number 6, where we need to go to each PC and issue the appropriate command to release the current IP address assignment and renew them, so we can see the new changes that we have just pushed into the DHCP server. So I'm going to go back to my topology, and I will go to PC1, and then I'm going to go to desktop. Just make sure that under IP configurations that the DHCP has been selected, and then I'm going to close this window, and then I will go to command prompt, and at this point I'm going to say IP config /release. So at this point we have released all IP address configurations from PC1, and let's renew all these configurations once more. So I'm going to up arrow this, and I'm going to change the command from ipconfig /release to /renew. And as you can see, we have received an IP address from the DHCP server with 10.1.1.101. The subnet mask is /24. You can see the default gateway is 10.1.1.1, and also you can see the DNS information as you can see on the screen. If I then issue IP config /all, what I wanted to show you is this first line, which is the DNS suffix. You can see that the domain name has been configured and pushed to the end devices, as you can see on the screen here, where it says iee.com. So I'm going to do the same thing on PC2, PC3, and PC4. So I'm going to go back to PC2. I'm going to go to desktop, IP configuration, make sure that the DHCP radio button has been selected. And then I'm going to jump into the CLI. And again, I'm going to say IP config /release and then renew. And you can see that we have received the second IP address, which is 10.1.1.102. The subnet mask is /24. The default gateway is 10.1.1.1. And the DNS server is 8.8.8.8. I will jump into PC3 and do the same thing. And here we have received 10.2.2.101, which is the first available IP address from that network. Again, the subnet mask has been assigned accordingly, as well as the default gateway. This time the default gateway is 10.2.2.1. And finally, the DNS information as well. And again, you can see that the PC4 has received an IP address of 10.2.2.102, which is the second available IP address from that network. You can see the subnet mask has been assigned, as well as the default gateway and also the DNS information. Okay, so with that being done, what I'm going to do next, I'm going to jump back to PC1 and I will initiate a ping request to test connectivity between PC1, PC2, PC3, and PC4. So I'll go back to PC1 and from there I'm going to say ping 10.1.1.102. And you can see that we have reachability and connectivity between PC1 and PC2. Okay, so I'm going to do the same thing and I'm going to ping PC3 and PC4. So I'm going to up arrow this and I'm going to change the IP address to 10.2.2.102 for PC4. And we can reach PC4 as you can see on the screen. I'll do the same thing for PC3. So I'm going to change the last octet to 101 and I'm going to hit enter. And you can see that we have reachability and connectivity. Okay, so what I want to do next, I want to jump back to router 1 and issue a couple of commands to show you some DHCP statistics so that you will be able to understand the output from each command so that you can digest it and be able to troubleshoot any issues if there is a problem with the DHCP service. So I'm going to go back to router 1 and I'm going to say show IP DHCP binding. And here you can see there is a list of IP addresses that has been assigned to end devices. If we were to look at the first IP address, which is 10.1.1.101, is being assigned to this MAC address, and you can see that the lease expiration is not defined. I believe this is a packet tracer limitation issue, but if you were to look at this command on a real equipment, you will be able to see some further information related to the lease expiration. It will tell you how many hours left, etc, etc. And you can see the type of assignment has been done automatically. And just for further clarification, I'm going to go back to PC1 and I'm going to say IP config/all, and you can see this is the IP address that has been assigned to this computer, and here is the MAC address. You will be able to see the MAC address matches this entry, so it starts with 0002.4AB1.00BC. The same applies here, 0002.4AB1.00BC. So you can see how many IPs have been leased within your network. The other command that I would like to also show you is show IP DHCP Pool. Okay, so if we were to look at this output, you will be able to see a couple of sections. Each section represents a DHCP pool. So we've created a couple of DHCP pools. The first one is IEE network_1. And you can see the output of this pool here at the top section here. And you can see the name of the pool and you can see some properties related to that DHCP pool. So for instance, the utilization mark, the subnet size, the total addresses of that subnet, the number of leased IP addresses, and the excluded addresses as well. And finally, the pending event. Here it does indicate that there is only one network that is currently in use in the pool. And finally, the last section is basically a summary of that IP DHCP pool, where it does specify the number of leased IP addresses, which is 2. We know that we've got PC1 and PC2. We know that the couple of IP addresses that have been excluded, which is the 10.1.1.1 and 10.1.1.100. And also if there is any IP address that is being assigned to any other interfaces as part of that network. For example, if we created a loopback interface, let's say 10.1.1.2, you will be able to see that the number of excluded IP addresses will increment from 2 to 3. And also you can see the total number of subnets is 254. And also the same applies for the second network, as you can see on the screen here. Okay, so that's it folks for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.